This is Josh White with JW Math Tutoring. In today's video, I'm going to cover 9 problems from the November 2025 Digital SAT Math Test. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Before I start going through these problems from my November 2025 Digital SAT Math Official Test problem worksheet number 2, I just want to mention a couple things that I do at the start of all of these videos. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there will be a link to the PDF file that has all these problems in it, both in the description of the video and in the pinned comment of the video as well. Third, if you haven't done so already, please do check out part 1, basically worksheet 1, video 1, where I go through 9 other self-reported November 2025 problems, and also part 3, where I just briefly highlight 20 repeat questions that have appeared on previous exams before and that I've covered in previous videos, showing you exactly which video to go through to find it. And then, let's see, the other thing I wanted to mention is, I've gathered these mainly from Reddit, and again, they are all self-reported, so there might be details in these questions that are slightly different than a version that you had on your test. Or some of the questions here that I do might be free response, whereas they might have been multiple choice questions when you took the exam, if you had them. So just keep in mind, I've tried to reproduce the questions and make them as useful as possible, but there might be slight or minor differences in how I have them set up versus what you actually saw. And in addition to that, there could be other solution methods if a question was a multiple choice question, but I'm doing it as a free response one. So just please keep those things in mind as well. All right, so with all that being said, let's go ahead and start this November 2025 Digital SAT Math Official Test Worksheet number 2. Okay, so the first question here is the resistor question that a lot of people were mentioning and talking about after the exam. So you have this equation. It's about these two resistors that are set up in series. If you're taking physics, probably familiar with that. If you have not taken physics, then don't worry about that. It doesn't have anything at all to do with the problem. Basically, it wants to know, okay, what's the positive difference between A and B? And A and B represent the individual resistance in ohms of both of these two types of resistors. Okay, so here's essentially what's going on in this problem. First, I'm going to separate the two terms that are being added on the left to write them like this. X times 1/5 and y times 1/9. Okay, on the right side, we just have a number, 47 over 45. We keep that. All right. This over here on the right side is ohms. That's the unit that you use to measure resistance. All right, so that means that these entire expressions here, this has to be a number of ohms. This right here has to be a number of ohms as well. Okay, X is the number of resistors. So the unit on it would be just, resistors. How many you have? 5 resistors, 10 resistors, whatever it is. Same thing with Y, okay? The unit on it is resistors. Now, you're multiplying that by some number, 1/5 in the X case, 1/9 in the Y case, and that value is basically going to have units of ohms per resistor. And the reason is because when you multiply these two things together, the resistors will cancel out and you're just left with ohms. And that's what you want. You want this whole entire expression to be ohms. You want this whole entire expression to be ohms. Ohms plus ohms equals ohms. Therefore, A, which represents the resistance of an individual resistor, which would have a unit value or a unit of ohms per resistor. And similarly, B, would have a unit of ohms per resistor. Those are going to be represented by these fractions right here in the problem. So in other words, the 1/5 is equal to A. The 1/9 is equal to B. So the positive difference between them is 1/5 minus 1/9. Now you could just go and do this in Desmos, or you can get a common denominator of 45. It's going to be 9 over 45 minus 5 over 45, and that equals 4 over 45. Correct answer for this one is letter D. Okay, so that's basically how you work this problem out. All right, for the next question, this was another common problem that came up. There was a kind of like there was a similar problem to this that came up last year. I think it was I want to say it was in May, maybe possibly in June. But that one was a little bit different because that one you were given one function and then you were given two other new functions which were equivalent to it. This one, you're just given two different functions, some information about them, and you're asked, which of these displays the minimum value of the function as a constant or coefficient in this specific domain of basically x greater than or equal to 0. All right, so I think the easiest way to do this is to just visually go ahead and graph both functions. So go to Desmos, and then we'll just be able to work with specific numerical values and go from there. So f of x, the first function, a times 0.19 to the negative bx. Second function, g of x. Just go ahead and type that in. Little trick here, type the +2 first, and then put the x in. If you type the x first and then try to do +2, it like drops you down back to the main level, and you have to like go in and fix it and edit it anyway. So just a little tip there. And then add the +b at the end. Okay, now we have to pick numbers for a and b. A is greater than 1, and a is less than b, which really means b is greater than a, if you want to think about it that way. So I just said, let's let a equal 1.2, and let's let b equal 2. All right, so now I have both my functions, and I'm going to do one other thing that I forgot to originally. I'm going to add the restriction that x is greater than or equal to 0 on both of the graphs. All right, so now I have my two graphs. So what is the minimum value of each of these graphs? So let's start with the red one. Okay, so the minimum value is clearly right here. It is our y-coordinate, 1.2. Okay, do we see that value anywhere in f of x, the red equation? And the answer is yes, right here. A is equal to 1.2. So a is a coefficient, that's in front of this 0.19 here. So right off the bat, for this one, the answer is yes. So we're looking at either A or C. B and D are both out. Now, we go down here to look at the blue one. Okay, here's the minimum value, 5.93132. All right, do we see that number appearing anywhere in this function? No. A is 1.2. B is 2. We have a 1.81 here. So I do not see that minimum value showing up anywhere. Therefore, correct answer to this one is going to be letter A. It's the top one only. All right, now let's look at question number 3, the bottom of the page. So if you have an exponential function and it's the f of x or y value is increasing by 140% when the x value is increasing by 1/3, which of these functions below basically represents that situation or is a description, of that situation? So there's a couple different ways you could look at this. First of all, if you think about it, okay, say I started 100, right? 140% of 100 is going to be 140. You can take the 140%, convert it to a decimal, 1.4. You can multiply it by 100, and then notice we're right back at 140, right? So now, when we increase it by 140%, we have to take and add it to our starting value of 100. Therefore, our ending value would be 240. So we started 100, we ended up at 240. So how do you get from 100 to 240, by multiplying by something? Well, it's, 100 times 2.4, and that would give you 240. You can just divide 240 by 100 to get that value if you don't recognize it. So right off the bat, the answer is going to be here either C or D. By the way, A and B are wrong. A and B represent 40% increases, not 140% increases. All right, so now the question is, which one is it here for C versus D? So the thing is, you want the number to be multiplied by 2.4 when x increases by 1/3. So it's like, let's say you start at 0, and then you're starting at x equals 0, and then you're going to x equals 1/3, right? So if you start with 0, you would plug in 0 for both of these, and it'd be 2.4 to the 0, which is just 1. Now, if you plug in 1/3, I'll just label these, by the way, C and D. For C, 3 times 1/3 is 1, and 2.4 to the first is just 2.4. If you do it for D, technically 1/3 divided by 3 is 1/9, and you get 2.4 to the 1/9 power. Now, I don't know what that is off the top of my head, but we can just confirm that, yeah, it's 1.102. That is not equivalent to that's not the right number, but again, 1.102, not 012. The point is, it's not equivalent to a 140% increase. So the correct answer here is going to be letter C. Now, I'm going to show you an alternate way that you could do this in Desmos as well. So what you could do in Desmos is you could just start and go through each function one at a time. It's actually not going to take that long. So I'm going to type in the first function. Then I am going to find the percent increase when I increase my x value by 1/3. So in other words, I'm going to do f of 1/3 minus f of 0 divided by f of 0. This is the formula for percent increase, and of course I'm going to multiply it by 100. Notice this comes out to 40, meaning this function represents a 40% increase. Okay, so that's obviously wrong. Now if you wanted, so B is also going to be wrong, but just if you wanted to check it to be sure, just edit this here. Okay, not 140% increase. All right, so let's go back now and let's check C. Yes, notice that this comes out to a 140% increase when x is increased by 1/3. Therefore, that confirms C is the correct answer. All right, let's go to the top of the next page. Question number 4. Here we have a right triangle trig problem. So essentially what's going on here in this problem is you have a right triangle. Let me just make sure I match everything to my notes. You have the altitude here. It is perpendicular to the hypotenuse at point D. Okay, the measure of angle A is W degrees. The only reason I'm doing that is because people mentioned in the problem about like W and Z or something. And the measure of this other angle down here is Z degrees. Okay. If cosine W equals 9 over 41, then what does the tangent of Z equal? So there are two different ways you could solve this. I'm going to show you both of them. I think the first way is faster, but possibly not. So if you notice a couple things here, okay, this angle right here is W, some number. I mean, we're going to find it in a second, but so angle A is W. Angle C is 90 minus angle A. So this is 90 minus W, whatever W is. However, if you look at the small triangle now right here, okay, so we're looking at just this triangle, notice that angle Z is 90 minus this number, which means Z is really equal to W in this picture. And you could also figure that out if you took the similar triangles and drew them out and matched up the corresponding parts. But however you want to think about it, the measure of z and the measure of w are the same. So what that means is all I have to do is find the measure of the angle and then take the tangent of it, and that's going to be my answer. So I'm going to start off cosine inverse of 9 over 41. Now, this is obviously not correct because standard cosine function is not greater than 1. Or no, we're talking about angle measures, so never mind. But it's still wrong because it's not in degree mode. There we go. So let's just, whatever, let this equal to w to store the exact value. So w is 77.3196 whatever degrees. That means that down here angle C is technically 90 minus that. And then Z is just 90 minus C because they're the two acute non-right angles in that other smaller triangle. So notice Z and W are the same. They are both 77.3196 degrees. Okay, so what that means is all I really need to do once I find the measure of angle W is just do tan W, and there's my answer. 4.444, or if you want to do it in fraction form, 40 over 9, and that's it. So 40 over 9 or 4.444. That's your answer. You could type in either one of those. Now, here is a second alternate method you could use to solve this. Let me just look at my notes to make sure I get this explained properly. Okay, so the way I would look at this is as follows. Cosine W equals 9 over 41. That's also equal to adjacent over hypotenuse, right? What I'm going to do is I am going to, let me just make sure, I'm just, again, reading over my notes. Yes, okay. I am going to look only at the small triangle right here. So the adjacent to this angle in the small triangle would be this side AD, which is 9. The hypotenuse would be AB, which is 41. I need to find BD right here, and that I can just get by doing Pythagorean theorem. It's going to be 9 squared, let's get rid of this, plus, I'll just call it B squared, now use regression, 41 squared. Okay, so BD is equal to 40. Okay, so this side is equal to 40. Now, what I'm going to do is I'm going to use the geometric mean formula to figure out the length of CD. Basically, this part of the hypotenuse right here. I'll explain why I'm going to do that in a second. So, what we know from the geometric mean theorems is that the altitude to the hypotenuse of a right triangle, which BD is right here, 40, is the geometric mean between the two parts of the hypotenuse that it splits up. Therefore, if you just solve this for x, well, just multiply 40 on both sides, or you can go to Desmos, either way. X is 1600 over 9. Just leave it like that. It's totally fine. Now, when I'm looking at the small, the reason I did that is because now, when I look at the small triangle in the bottom, if I want to find the tangent of z, it's opposite, which I just found, over adjacent, which I found earlier. So, tan z equals opposite 1600 over 9 divided by adjacent 40. If you can't do this in your head, that's fine. Just go to Desmos. Type it in there. So we've got 1600 over 9 divided by 40. Right there, same exact answer. 4.4 repeating or 40 over 9 as a fraction. Okay? So that's an alternate approach you could take as well. I think the first method is faster, but either way is technically fine. All right, let's look next at problem number 5. So on this one, you are told that in a circle, the measure of an arc is 60 degrees, and you're also told, so like if you want to sketch out a little bit, a picture right here, here's A, here's B. Okay, the measure of this arc right here, 60 degrees. You're also told the length of the arc is 3 pi centimeters. What is the radius of the circle? Okay, so there's two ways you could do this. The first way, which is the way I did it, is I said, okay, 60 out of 360 degrees, right? That fraction of the circle, 60 out of 360, basically it's going to be 1/6 of the circle. If you multiply that by the circumference, that gives you the portion of the circumference, or the length of the arc, that corresponds to this 60-degree, angle here. Measure of an arc equal to the measure of its central angle. So you go ahead and you basically, okay, first of all, the zeros cancel out here. This becomes 1/6. And so what you end up finding is, okay, the circumference of the circle is equal to 18 pi. We just multiply by 6 by 6. And then you could say, well, circumference is 2 pi r, so you divide by 2 pi, and the radius equals 9. Okay? So that's the first approach. That's basically the way that I first initially thought, how to do it. Now, a second approach you could use, and this is something that you generally don't learn until pre-calculus, but if you have learned it and are familiar with it, this is fine, is basically the equation S equals r theta. So in this equation, r, of course, stands for our radius. Theta is the angle measure, which is the same as the arc measure, but it's in radians, not degrees. And S is equal to the arc length, which we are given here, 3 pi. So you would plug in 3 pi, r we're solving for. Now what you would have to do is you have to convert 60 degrees to radians. Okay? So if you have that memorized, say because you learned the unit circle, it's pi over 3. If you don't have it memorized, you take 60, you multiply it by pi over 180, and then 60 over 180, or 6 over 18, reduces to 1 over 3. Therefore, you plug in pi over 3. So now you could just go ahead and solve this for r. Again, you could go to Desmos, you could just type this in, but I'm just going to do it by hand. Multiply by 3, so you get 9 pi equals r pi, and the pi's just divide out and cancel, so r equals 9. Same answer. Alternate approach, use whichever one you are most familiar with, or whichever one you think is faster. All right, let's look at the next question now, number 6. This one deals with a data set that has some constants in it, A, B, and C, and you're given some information about the data set, such as the mean, the median, the range, and so on. Okay, so a couple things. First, there are 7 items in here, and since they're listed in ascending order, that means that the middle value is the median value, right? Because basically the 4th value in this list of 7 will be the median. Therefore, that means B has to be 32. Okay, so right off the bat, we know B is 32. Then, excuse me, we know that the mean between these, we know that the mean is equal to 34. So you add everything up, it equals 34. So basically, what we're going to do is, okay, so the mean would be A plus 25 plus 28 plus 32 plus 40 plus 42 plus C. And then, so this divided by 7 would equal 34, right? Just to find the average. However, we know that the range is 65. So here's the thing. This equation currently has 2 variables in it, or 2 constants in it, A and C. Okay, we need it to only be in terms of 1 constant to be able to solve this. So we know that the range is the difference between the highest and lowest value. So C minus A equals 65. What I'm going to do now is I'm going to add A to both sides, C equals 65 plus A, and then subtract 65. So now I get A equals C minus 65. And I can take that and I can replace that in here for C. Now you have an equation you can solve. Now, I'm not going to bother doing this by hand because we can just go to Desmos and just type the whole thing in Desmos. If we want to use, if we want to keep using C, then I'm just going to use regression. So it's going to be c minus 65 plus 25 plus 28 plus 32 plus 40 plus 42 plus c, divide by 7, tilde 34. So the value of c is 68. That's your answer. That is what you would type in. Couple things. First, alternate approach to this. Get rid of the divide by 7. Put mean. And now you could also enter them in like this. So instead of actually typing out the formula, right, you could just type like the mean of and then put all these values. Close the parentheses. Okay, so right there again, I get 68. Same answer. If you think it's quicker and faster to type this, totally fine. Lastly, here's how you could solve the whole thing just using a system of equations in one shot. So what I would do now is I would say the mean of A, 25, 28, 32, 40, 42, and C, comma, let me close this, tilde. Okay, so we know that is equal to 34. We also know, and this is where the system of equation comes in, C minus A is equal to 65. So notice here, it's not giving me the right value. So why is it not giving me the right value? Probably, did I mistype something, or do I need to add a restriction that like A is a positive number? Mean is 34, 25, 20. Oh, I just realized I mistyped it. There we go. Just a typo. 38 corrected to 28, and now notice it gives me the correct value for C, 68, also tells me that A is 3. So this is how you could do the entire problem in Desmos, just setting up a system of equations. All right, next question. So this is one that is in the question bank and has come up repeatedly. There are couple different approaches you could use this. This is the one where you're given 3 points of a triangle and it's asked for the area formed by them. The biggest common mistake people make is they assume that this is a right triangle and they just find the distance between, say, two of the sides, and then, one of them is the height, one of them is the base. They, multiply them, multiply by 1/2, and so on. But that's not correct. Instead, I guess I would say the easiest or most common approach is to kind of make a giant rectangle which encompasses the triangle here. And the way I'm going to do that is basically go over like this. Okay, and then the actual triangle we want the area here is this red one. Okay, essentially we want all this area inside here, right? That's what we're looking for. Okay, so if you do this, the area of the rectangle will be 1, 2, 3, 4, 5 by 1, 2, 3, 4. 20. Length times width. Then we have 3 small triangles to basically go through and add up and find the area of. All right, looks like I labeled this triangle 1, triangle 2, triangle 3. So the area triangle 1 is going to be, let's see, it has a base of 2 and it has a height of 4. So 1/2 times 2 times 4. Well, that should just be 4. Area triangle 2. Okay, this has a base of 3 and a height of 3. Therefore, its area 1/2 times 3 times 3, 9/2. Area of triangle 3, height of 1, base of 5, 1/2 times 5 times 1, 5/2. So you now add these 3 all up, and then you subtract that from the 20. Get rid of that. That's the 9/2. So I would just go to Desmos to do those calculations. 20 minus 4 plus 9/2 plus 5/2. You get 9. 9 is the correct answer here. And that's what you would fill in. Okay, so that's one method. Alternate method you could use is Heron's formula. Heron's formula, again, if you haven't learned this, like, that's fine. I wouldn't worry about this. But if you have learned it and familiar with it, like I'm going to do all the calculations in Desmos, but I'll show you how it works out. So essentially, you're going to have three sides. I'm going to call one of them A, one of them B, and one of them C. First one is going to be the distance between, and let me go back to the picture and just erase some of this stuff so I can put the various coordinates on here. Okay, we've got 4, 3, we've got 2, 7, and we've got 7, 6. So let's do the distance between, oh, actually, no, this is the way I want to do it. Sorry, I want to define the points. Yeah, I define the points first. That way it'll be a lot less typing. Okay. So a distance between A and B, distance between B and C, and lastly distance between AB, BC, and A and C. Okay, so those are my three distances. Now, for Heron's formula, you have to first find the S value, semi-perimeter. That is going to be basically the three things, the three distances, I'm just calling them A plus B plus C, all divided by 2. Okay, so now what I'm going to do is, I just slide this up here. Let me just see now. There we go. Yeah, I want to define these as letters. So now I'm going to define S as A plus B plus C divided by 2. Okay, that should be my S value. And now what you do with S for the actual formula is we take, let's write it down here. This is the final answer. The square root of S times S minus A, which is the length of the one side, times S minus B times S minus C. So now let's do the square root of S times S minus A times S minus B, S minus C. Okay, so we go through all this work. We get the same answer of 9. Again, I tried to make the work as painless as possible by defining the points so I can just type the letters instead of having the actual typing the points out and so on and so forth. And we carry through all the exact values and you get the same answer. So if you want to use that method, that's fine. Draw a rectangle and subtract the 3 areas method, I think is quicker. There's also the shoelace theorem that you could use as well. I'm not going to bother demonstrating that because most people have not seen that and have not learned that. So I'll just say that is an alternate third approach you could use. I'm not going to bother, like I said, not going to bother demonstrating it here though. And technically there is a fourth method you could use as well. So you could, in Desmos, basically, you could find the equation of this line, and then you could find the equation of the line which is perpendicular to it. And then you could find, finding the distance, and you could find the distance here between these 2 points. And then you could find the distance between this point, this vertex, and the point on this side, which is, it intersects it at. The perpendicular line intersects it at. And then that would be your height, and this would be your base, and then you could plug it into 1/2 base times height. I've demonstrated that before. I may put the Desmos link in the description if you want to see it, but I'm not going to, I guess I'm not going to spend the time going through it now, but I'll make a note to just put the Desmos link in the pinned comment of the video. All right, let's look next at question number 8. So on this one, you have a table. It's got some percentages for various age groups. And it basically wants to know, this is a conditional probability problem. Okay. You choose someone at random. What's the probability that the person is greater than 60 given that the person is at least 18 years old? So all we're doing here is we're basically saying, okay, probability greater than 60, probability greater than or equal to 18. So probability greater than 60, well, that's 0.27 or 27%. Probability greater than or equal to 18. That's the sum of these three groups right here. Okay, that's basically like all the groups except the under 18. So you add these up, 27 and 23 is 50, but 75. So the answer to this is just 27 divided by 7, or 0.27 divided by 0.75. It's just 36%. Here I had the instructions to write the answer as a percentage but not include the percent sign, so you would just type in 36. If they wanted as a decimal, it would obviously be 0.36, but typically with these problems they put it as you would put it as 36, the actual percentage value. All right, last question, number 9. We have a formula problem here. I just want to solve this formula, this equation for D. Okay, so if you want this, first of all, this thing here, this is basically irrelevant. This doesn't really matter. This is essentially is done to ensure that whatever the radical is positive. But if you want to do this by hand, you would just subtract 4c on both sides, 9d minus 4c, and then you square root both sides. And of course, when you introduce the radical into a problem by square rooting, you have to put a plus minus. So final answer, plus or minus square root of 9d minus 4c right here. Okay, correct answer is going to be letter D. Now, you could also do this in Desmos. Don't know that it's necessarily any quicker, but let's take a look at it just to review solving formulas. So we type the first formula, the original equation or formula in, but we do use regression. And it'll give me values for B, C, and D here. Okay. Now, if you want to check that everything here meets the given conditions, you can do 4/9 times C, and I can check, is this number less than D? In other words, is the D value, which is 0.5 repeating, greater than this 4/9 C, which is 0.4 repeating? The answer is yes. Okay, so the numbers it chose are fine for the conditions of the problem. Now we just type the answer choices and see which one is equal to 1. All right, not that. Okay, does equal 1. E plus 4c. Okay, not that one. So right off the bat, notice because of the plus or minus, it could be plus or minus 3, but the number's wrong anyway. So, okay, these two are out so far. Let's look at D. Okay, so we have two choices so far that could be correct. So in this situation, what you would have to do is you would have to pick a number or define a value for one of these to try to get some different things. So let's say I'm going to let C equal 2. All right, notice it doesn't change my B value. All right, what about if I make C equal 2 and now D equal 1.5? Okay, perfect. Notice when I do this, now it gives me a different b value other than 1. It gives me this 2.34521. Okay, now when I compare the answer choices, I can clearly see it has to be D. It's not going to be B. Okay, so sometimes on formula questions, if you're using Desmos to solve it, you might need to pick a number for one or more of the letters in the problem in order to distinguish between two or more of the answer choices. All right, so I hope you enjoyed this video. November 2025 SAT official test problems worksheet and video number 2. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments or alternate solution methods, please do leave them in the comment section below. Otherwise, if you haven't done so already, please check out part 1, basically November 2025 worksheet and video number 1, which is already posted. And also check out part 3, which will have 20, which will highlight basically 20 of the repeat questions that appeared on the November exam that were previously covered, previously appeared on exams from earlier months, or either earlier this year or even last year. And lastly, if you're looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It is over 5.5 hours of tips and tricks and instruction, including 65 practice problems covering all of the advanced skills and operations in Desmos to help you ace the digital SAT math section.